So here's the midterm review target sheet. What we have here in this box is we're going to look at our position versus time graphs and our velocity versus time graphs. Each of these things in the empty box, we're going to put our part of the graph that tells us that thing. So the first thing to look at is the initial conditions. Now these initial conditions, it could be a positive, it could be negative, or it could be zero. And the two things that we may find out for an initial condition, it's going to be either the initial position or the initial velocity. Now on both of these graphs, it's the y-intercept. So the y-intercept on a position versus time graph is going to tell you the initial position. The y-intercept on a velocity versus time graph is going to tell you the initial velocity. So initial position is with position versus time graph. Initial velocity is the y-intercept on a velocity versus time graph. Now direction on a position versus time graph. First off, direction of an object can be positive or negative. Typically to the right is positive, to the left is negative. On a position versus time graph, the slope tells us if the direction is positive or negative. So a positive slope, something like this would be a positive slope, versus a negative slope. We could also have a positive slope that is a curve, or we could have a negative slope that is a curve. So there's a couple different options like that. The slope of a position versus time graph tells us the direction. For a velocity versus time graph, it's the quadrant that it's in. Or you can think about it as above or below the time axis. So if the line is above the time axis on a velocity versus time graph, the object's moving in a positive direction. If it's below the time axis or in the lower quadrant or the fourth quadrant, has a negative direction. Be very, very careful that you don't switch those. Don't do that. That's a very common mistake where people will talk about the slope of the velocity versus time graph being the direction that the object is moving. Likewise with the quadrant. The last thing we're going to look at is speed. So what part of the graph of a position versus time graph tells us whether the speed is constant or zero or increasing or decreasing? This is the steepness of the graph. Now some examples here, we could have a very steep graph or a very shallow graph. Maybe that's not too shallow. There's a very shallow graph. Whether it's steep like this or steep like this does not matter. Those are both very steep graphs. Here we have a graph that's getting steeper and steeper and steeper. It's getting more and more negative. Here we have a graph that's getting steeper and steeper and steeper. The slope is getting more positive. Now on a velocity versus time graph, how do we know about the speed? Well, that's if it's going towards or away from the time axis. Now if we were to sketch a graph here, remember with the velocity versus time graph, write in numbers or write in 0, positive, and negative. And any line that's going towards the time axis is heading to a velocity of 0 meters per second. So that means it must be slowing down. Any line that's going away from the time axis is heading away from 0 meters per second, so it must be increasing its speed. So in general, how does this work? Well, the physics concept. So that may be the initial velocity, or that may be the direction, or the initial position, or maybe the speed. So one of those is going to go on here. So an initial condition, initial position, initial velocity, direction, or speed is, and then we have our options, positive, negative, or 0. Positive, negative, 0, constant, increasing, decreasing. It's going to go here. So you may say, oh, the speed is increasing because put in the part of the graph. So it may be the steepness of the graph, if you're talking about position versus time graph. Or maybe it's the line is going towards or away from the time axis. So we'd say, oh, the line is going towards the time axis, or the line is getting steeper and steeper. So that's how we would write all that out using this vocabulary down here. Now, if we go down to Unit 2, Lt6 Explanation with forces. So relevant forces, what does that tell us? Relevant forces tell us the net force. Or we can just write it as F net. An example. So let's say we have two objects. We have an object here. We have two forces on it, force of gravity and force of tension. And we would say, if we're looking at these, if this is our given, since, you know, Ft is greater than Fg, F net, so this is the given is here, F net points up. So now that we know the net force causes acceleration. And we're going to use the same example, same FBD here. And so we'd say since F net points up, so does acceleration. F net causes acceleration, so whatever direction the net force points, acceleration will also point in that direction. All right, acceleration and velocity. So acceleration, the direction of acceleration, the direction of velocity, they tell us, this is a longer one, whether an object is increasing speed or decreasing speed or constant speed. So the third thing, if we were kind of going in this direction, if we were given the relevant forces, we talk about net force and acceleration. And once we know acceleration, we can say something about the velocity. So some examples down here. So for instance, if the acceleration points up and velocity points up, this would be increasing speed. If acceleration points up and velocity points down, they're going in opposite directions, so this would be decreasing speed. Notice I didn't say acceleration is going in. Acceleration is not going anywhere. And acceleration itself is not getting bigger or smaller. It's the direction that it points. So I'm going to use the phrase acceleration points up, acceleration points down. So then lastly, if acceleration is 0, so that has no direction, and let's say velocity is going up. Whoops, I messed up here. Acceleration, oh no, we're good. If velocity is going up or velocity is going down or any direction, we'd call that a constant speed. Now, one thing to remember here is that our logic, our explanations sometimes go this way. If you're given the forces, you have enough information to do the forces, so the explanation might go this way. This is sometimes. Other times, you may be told something is slowing down and moving in a certain direction, and then the explanation is going to go this way. So it just depends. Usually if you're given something about the forces, if you can figure out the specific forces, you're going to go this way. If you're told, or you can figure out told what direction it's going, and if it's speeding up or slowing down, it's going to go this way. All right, so that is an overview of both learning targets on the midterm, using parts of a graph for LT4 for Unit 1 and explaining graphs, and then using relevant forces, net forces, acceleration, and velocity to construct some explanations with Unit 2 and forces.